Good. So today we are looking at the regression assumptions. The regression assumptions, they are the ones that we continue with. We had discussed the first assumption in the previous lesson. So today we now start with the second one. And the second one states is called zero mean for the error terms. For the error terms, zero mean for the error terms, and the error terms are E, which is equals to y minus y predicted, y minus y predicted assumption. So the zero mean for the error terms assumption. And we write that this states that the error terms have a sum of 0, have a sum of 0 and a mean of 0. And a mean of 0. That is, E bar is equal to sum of the EI's, you divide by n, and this is 0, you divide by n, and you get 0. You get 0. And we write that if a non-zero value is obtained, it is tested whether it is significantly different from 0. Whether it is significantly different from 0. Stop. For the above case, E bar equals, now I want you to go to your table that we have prepared and you give me the total of this, y minus y bar. So y minus y predicted, total we got what? 2.22. So it is 2.22 and all the values were 10 or 12. 12. So divide this 2.22 divided by 12, give me to 2 decimals. 0.185. 0.185. Now, in this case, you can see we have not gotten a value that is equal to 0. But when you compare this value with the values of y, then we can comfortably say that this is almost 0. Because the values of y, you can see they're in hundreds. If you look at the table, you can see that the values of y are in hundreds. So getting an error of 0.18, that is almost 0. Good. So let's go to assumption number 3, which is called constant variance. Constant variance for the error terms. For the error terms. Assumption. Constant variance for the error terms assumption. And we write that this states that the error terms have a constant variance of 1, since they do not depend on the values of x. That is, the data is homoscedastic. If the values of the errors appear to depend on the values of x, the variance will be more than 1. And the data is said to be heteroscedastic. This assumption is tested by visual inspection. Or by plotting a graph of the values of x and the error terms. Okay, so now I want us to go back to the data. Look at the data that we have. And you tell me, when you look at those error terms, do you think they are changing? Or rather, what is the first value of x? 51. The second value, 45. Third value, 51. I end up by column here, y minus y predicted. The first error is 11.83, then or 111. Then 108.41, then 81.83. Now, first of all, you can see here that these are the values of x and these are the error terms. If they were depending on values of x, where we have equal values of x here, even the errors should be equal. But you can see they are not equal. And then you can see, they are not equal. So that tells you they are not depending on the values of x, and therefore our data is what? Homoscedastic. And if you're not able to see it clearly from the values, the absolute values that are on your table, what you can do, you simply plot a graph. And that graph will be able to clearly bring out the pattern, and you'll be able to know whether they are depending or they are not depending on the values of x. Okay, number 4 is normality for the error terms. For the error terms assumption. Normality for the error terms assumption. Normality for the error terms assumption. Normality for the error terms assumption. And we write that this states that the error terms follow a normal probability distribution, with a mean of 0, and a variance of 1. And a variance of 1. It is tested by computing. Those values, or by plotting, a normal curve. By plotting a normal curve. So what we are saying, you see now in this assumption here, we have said that the mean is what? Is 0. We have said here that the variance is 1. Now, these are the main characters of something we call normal probability distribution. So what you do if you want to test this, you simply compute this. You get a 0. You compute this, check whether you get 1. And if yes, that confirms that the errors follow a normal probability distribution. And number 5 is called independence. Independence of dependent variable. Independence of dependent variable assumption. Independence of dependent variable assumption. Dependent variable assumption. And write that this states that the values of the dependent variable, are independent of each other. It is tested by visual inspection. Or by computing Durbin-Watson statistic. Durbin-Watson statistic, DWS, which is equal to 2, 1 minus R, which is equal to 2, 1 minus R. Then we write that if the computed value is in the range, of 0 to 1, sorry, it's 0 to 4, 0 to 4, it means there is no autocorrelation. There is no autocorrelation or serial relationship. Serial relationship. That is, the values of y are not influencing each other. That is, the values of y are not influencing each other. Values of y are not influencing each other. For the above case, DWS calculated is equal to 2 brackets 1 minus, I think we got 0.5. That was our value of R. So this then gives you 1. This gives you 1. Then we write that this means that the values of electricity expense, in the above case are not influencing each other. In the above case are not influencing each other. Are not influencing each other. Okay. The last assumption, number 6, naitwa independence of independent variables. Assumption. Independence of independent variables assumption. And we write that this states that the various independent variables in a multivariate function are not influencing each other. That is, there is no correlation. Sorry, there is no collinearity. Collinearity, that is x equals to all multicollinearity. X is greater than or equal to 2. There is no collinearity, x is equal to 2, or multicollinearity, x is greater than or equal to 2. Stop. If the values are influencing each other, so if the variables, let's take it that way. If the variables are influencing each other, if the variables are influencing each other, the remedy is to drop off one of them. drop off one of them. Stop. This assumption is tested by computing. This assumption is tested by computing correlation coefficient. Correlation coefficient between the variables. Between the variables and preparing a correlation coefficient matrix. And preparing a correlation coefficients matrix. Now you can prepare something like this: x1, x2, x3. The matrix, the correlation coefficients matrix. So this is 1. This is R between 2 and 1. R between 3 and 1. This is 1. This is R between 3 and 2. This is 1. A minute.
Cheki, ulize, imepata sio? Unaweza nibukia huduma? Ama tu kama tukacheki huduma basi. Oh, na kama ndo by that. Ati? Lakini shaka nina chai. Nina chai shule, kuna chai yangu. Basi na chakula nao. Anything. Thank you. Ah. Siku ina chai. Au nikupa. Lakini nakula masiasi mbili. Nini? Lakini sawa, ileta nimekia ndio safi. Asubuhi nilikuwa kwa kuandikisha. Bye. Mahali kana tunasabela. Cheki video za stories. Na tumekurumia tukisapa hapo. The notes from Palestine. I put everything I'm writing down, right? Or put still a book game of check it. Ikaw. When economics, sini nilai sa kaya ko no? Nilai ba? Basi ko dito. Poi fica la luce che buchiamo ya male da quanto non economics full bro. Full. E mi economics full ma che quando sei non riesco mai a fare uno gli di massimo però non è cosa si dice per andare a non لكن كمان special exam 45 kwa. Wow. Mimi nakwambia lakini exam econometrics napiga 100 bro. Kama sina kufanya kitu hapa. Uko na hela wala. Inshallah, haifai.
Good. Then down there you write that if the correlation coefficient is greater than 0.8, the variables are said to be influencing each other. The variables are said to be influencing each other. The variables are said to be influencing each other. Okay, so those are the 6 assumptions that we have. Now, the next thing that I want us to look at is called interpretation of Anova tables. Interpretation of Anova table. Interpretation of Anova table. Interpretation of Anova table. Now, Anova table is what you get when you solve regression using a computer. So what we have been doing to make what to solve manually using a calc. But if you're using a software like advanced Excel or just normal Excel, ama hizi statistical packages, they will give you some results. Now, these results are the ones that I want us to interpret. That's a minute. So, nimesema this is what you get when you have so Anova table illustration. Illustration, Anova table. Illustration of Anova table. So I needed only, I needed 4. This one is not there. Total. Need residual. Need regression. Need DF here. 1, 3, 4. Need SS. This is 8. This is 7.95.2. That is 6.667. 0.00904. That is how it looks like. Okay, point number 1. Look at DF means degrees of freedom. Degrees of freedom. When you see DF, this one, inamaanisha degrees of freedom. And I think we explained the other day, tukasema, this is the number of choices you can make without consulting anyone. Number 2, regression DF. Regression DF. Regression DF is the number of independent variables. The number of independent variables. The number of independent variables. And in this case, it is equal to what? 1. And if it is 1, that tells you that you are dealing with an equation of whose format is y is equals to a plus b x, which we called simple. Yeah, this one we called it simple. And then it also tells you something that k is 2. You remember what we talked about k? Lazima k is this one, a and b. Yeah. Number 3 is residual df. Residual df. Now, residual df is equal to n minus k. That's how it's given, n minus k. So the answer, the value here is 3. The value is 3. So if it is 3, it tells you, you can be able to say n minus k, which we know is 2, is 3. Therefore, n should be 3 plus 2, which gives us what? 5. That tells you that the number of items are 5. Point number 4 is total BF. Total BF. Total BF. Now, total BF is given as n minus 1. N minus 1, which is equal to 4. Which is equal to 4. Now, with that formula, you can be able to say that then n should be 4 plus 1. And that gives us what? 5. N is 4 plus 1, which is equal to 5. Alternatively, if you are looking for total BF, you can get it as regression BF. Regression BF. The short form for the word regression is REG plus residual BF plus residual BF. Now we know that the regression BF upper was what? 1. And the residual, tunajua it was what? 3. So when you add, you see they take us back to 4. Yeah. When you add, they take us back to 4. These things you use, did you do a project at the university? These things, yeah? Okay. Even when you're doing a project, chapter 4, 5, they are about this. Yeah. Then, tulikuwa tumefika point number 5 or 4. 5. So point number 6 is now I should write 5. Eh? Okay, so 5 is SS. When you see SS, it means sum of squares. Sum of squares. That's why regression analysis is also known as least squares method. And the other one for this one is variation. Variation. It has very many names. You can also call it variance. You can also call it variance. And you can also call it error. Some people prefer to call it error. So all those are names of SS. Point number 6 is regression SS. Regression SS is what in our notes we called explained variation. Explained variation. And this is in the 8. Explained variation, which is in the 8. Now, the next thing, number 7, is residual SS. Now, residual SS is what in our notes we called unexplained variation. Unexplained variation. This unexplained variation is 7.2. Unexplained variation is 7.2. Now, when we are here, we can be able to remember the formula of SE, the standard error of estimate, which we had said it is the unexplained variation 7.2. You divide by residual degrees. Residual degrees, we know they are 3 here, and then you get the square root. So give me the answer. 1.55. 1.55. Point number 8 is total SS. Total SS. Now, total SS is what we call total variation. Is what we call total variation. And this total variation, it is what we will call regression SS plus residual SS. Regression SS plus residual SS. And you can see clearly that if you want to take 88, you add back 7.2, you will get 95.2. You will get 95.2. Now, when you are here, you can be able to compute R squared. You can be able to compute R squared. If you remember the formula we gave for R squared, to the same mark, it is the explained variation. That is 88. You divide by the total variation. You divide by the total variation, 95.2. You can either give it as a decimal or you can multiply by 100. Give me now as a decimal, 2 decimals places. 0.92. 0.92. Still, when you are there, you can be able to tell me that R is the square root of R squared. So if you got the square root of that value that you have just gotten, that will give you the correlation coefficient R, 0.96. 0.96. Okay, point number 9 is MSS. Point number 9 is MSS. Now, MSS, it means mean sum of squares. Mean sum of squares. Mean sum of squares. And this mean sum of squares is equal to SS you divide by DF. SS you divide by DF. Sasa kuna mwingine sasa hapa anaitwa regression MSS. Now this regression MSS, it is given as the regression SS you divide by regression DF. Regression DF. Regression SS you divide by regression DF. So this one will be 88 you divide by 1, and the answer is 88. That is how this 88 is arrived at. Haya, tuende kwa huyo mwingine number 11 anaitwa residual MSS. Residual MSS, it is given as residual SS you divide by residual DF. Residual DF. So residual SS is 7.2 divided by 3. Check whether it is the one giving us 2.4. Yeah, it's the one giving us 2.4. Point number 12. Point number 12. Point number 12 is F. Now, this value that you can see here being called F, it is F calculated, is what we call F calculated. And F calculated in this table is given as regression MSS, you divide by regression DF. Regression MSS, you divide by regression DF. So this becomes 36 point, not 36. That's the answer. But before that, we need 88 divided by, sorry, not that. Yeah, it is the regression MSS. Sorry for that. Residual MSS divided by 2.4. Is the explained, you divide by the unexplained. The regression MSS, you divide by residual MSS. Check whether when you do that, it gives you that 6667. Yeah. Okay. Then number 13, it is significant or sig F. Now sig F, it is what, in other words, you can call significance F, and this is what we call F critical. It's simply F critical. Now this one, it is just, you just pick the way it is given in the table, 0.00904. So those are the points that you need to remember. Now, there are two ways in which the examiner can present this question. Number one, you are given missing values. You are given missing values. When you know the relationship between the values, now this one, this is a relationship of three values. So the examiner can give you two of those three, and you are told now to get the other. So if you know how they are related, then it becomes very easy to get the missing. That's the first type of questions. The second type of questions that you can get from this is where you are told to interpret or to comment. For example, you see now this is F calculated and this is F critical. Na tulifanya F test. Na tukasema if the F calculated is greater than the critical, like now this one, naona hii ni kubwa kuliko hii, it means the relationship is significant. Yeah. So you can be told to interpret. Ama hiyo R square ni compute hapa. The same R square shows the amount that is explained. So ukisha compute upate hiyo ni 92, then you simply tell us 92% of this is explained by this. So those are the two areas the examiner can test you. Now, for now, I want to give you an assignment. Assignment. Determine the missing values. Determine the missing values. The missing values in the table below. In the table below. The table below. So if the computer was to give you such a printout, like you to get there. So you can leave just a small space. Haya. Mengine, there are two tables, There are two tables that you get. So the next table is called interpretation coefficients through estimates. T. So illustration. Illustration. So explanations. Point number 1. The column of details. The column of details contains the words intercept, stroke constant, and the names, stroke abbreviations, of the independent variables. Of the independent variables in the function. Okay, so I think that is very clear. Point number 2. The column of coefficients. Contains solutions for the equation. Still on the same point. The column for the coefficients contains, oh, you're writing again. Sorry, I'm repeating for Yusuf, sorry. Yusuf, I'm saying the column for the coefficients contains solutions for the equation. Is that okay, Yusuf? You're saying point number 1. Point number 1, I had said the column of details contains the words intercept, stroke constant, and the names, stroke abbreviations for the independent variables in the function. Is that okay, Yusuf? Good. So point 2 we had gotten, and tukasema it contains solutions for the equation. So the other point that I wanted you to add there is that all these values are together known as slopes. Brackets B. So at that point, you can now be able to write the equation. The equation is y is equals to a plus bx. So y will be equal to 0.55851 plus 0.04375 x. Point number 3 is that the column of error represents the started error for the throat. Presents the started error for the throat. And you can write the formula SB is equals to B out of sorry, no. So that one will appear in there. The started error for the throat, SB. Point number 4. T statistic represents T statistics represent T calculated. T statistic represent T calculated. So then you can write T calculated is equals to SB out of B. Is equals to B out of SB. T calculated is equals to B out of SB. And you can confirm one. You can confirm kama hii 0.55851. If you divide it by 0.18707, it should give you 29.8554. And finally, that should be 0.405. Fine, right? So CT is equal to T critical. Sig T is equal to T critical. So that is how they are interpreted, and that is good. I want you to look at your past papers. You go to page 146. Page 146, you will find a question of December 2004, question 1. December 2004, question 1. And I just want us to comment. There is correlation matrix. Correlation matrix. Correlation matrix. Now that correlation matrix, we have production here. We have the index. We we have production here, and we have the index. This is 1.00. This is minus 0.087. This is minus 0.087. And this is 1. So the comment that we can make now are between production and index equals to what? Type of relationship. Type of relationship. Or linearity. Now this nataka unijazie tu sahi in the next 2-3 minutes. Nataka uniambie the correlation coefficient between the two hapa. Type of relationship. Uniambie kama ni direct, ama ni inverse, ama ni null. Na uniambie collinearity whether it is present or absent. Okay. No. Unaandika minus 0.087. That's the correlation coefficient. Ukiangalia ile matrix tumechora kwa, hebu angalia kwa assumption number 6. Assumption number 6. So naona hiyo matrix the R. Yeah. Na kwa hiyo matrix unaona hatukuandika hii value hapa juu because inafanana. So we normally write just one. Naja. Haya. Type of relationship. Nilikufunza types of relationships. So is this direct or inverse or not? Haya, kipia hapo kwa notes. Hadi tulianzia. Regression analysis. I taught you types of relationships. I think mahali tulisoma regression analysis method. Umeona? Hatukuongea mambo ya direct, mambo ya inverse. It is inverse because it is what? Negative. Haya, collinearity. Nataka uangalie tena kwa hiyo assumption ya number 6 Tumesema the variables are said to be collinear or to influence each other if the correlation coefficient is what? Among the last statement we make. Greater than? So is this greater than 0.8? And remember when you are measuring collinearity, we don't check the sign. Yeah, so it's not greater. So that means it is absent. Absent. Collinearity is absent. Yeah. So those are the comments that you can make for that. So, time naona meisha. I would like you to look at this question on page 140. Page 140. A question of June 2005, question 1. June 2005, question 1. I will begin there when we meet next. God willing. Begin there. That's the question I will solve when we meet next.